I always loved adventure games like Zelda, but since there are already tutorials about 3D movement and actions, I decided to make my very first tutorial about element interactions like fire that can be later used to build and solve puzzles. Let's take a look at the assets I used to make this project. The character model and controller come from Open 3D Mannequin by GD Quest, while Fire Shader and Particles are from Shader Secrets, also from GD Quest. To set up the scene, I used Material Maker and a couple of already available materials for walls and floor. As you can see, the scene is very simple, just a room with a few torches. Big torches are just static bodies with a simple box collision shape, while end torch is a rigid body with a script attached to make it follow the player's end. To keep the end pose, Mannequin was modified using an inverse kinematics bone for the end and a couple of positions as eye key targets. When we press play in the dungeon scene, we can walk around with the torch. The first scene we are going to make is an area with a simple collision shape. We can use a sphere, but now it's not that important. We call the scene Burnable and save it before attaching a new script. We start by adding a couple of signals. Burnable object will use them to communicate that a fire has started or that it has completely burnt out. Then we add a few export vars. Burning will allow us to turn on or off the fire. Permanent will allow an object to burn indefinitely. On the other hand, max seconds will be used to turn off automatically non-permanent flames. Then we have elapsed seconds that will keep track of elapsed time, and flame that is a reference to a flame object we will make later. We set it to null, meaning there's no flame attached. In the ready function, we will add the scene to burnable group. Then we create a setter for burning. First, we check that the new value is not the same as current. Then we update burning value. If it is true, we reset elapsed seconds. While if it is false, we call method die on flame and set it to null. This is necessary because queue_free method may not delete the object immediately, and we need it to be null if we need to light the fire again. In process function, we check if the object is burning. If not, we return. Then, if the flame is null, we emit a signal to light the fire. We could have done this in burning setter, but since it is an export var, its value would be evaluated before ready is called. This would make it impossible to use yield to wait for the whole scene to be ready. And on launch, the signal would not be captured by the component responsible of adding the flame. Finally, we check if the flame is permanent, and if not, we update the timer and perform a check. If enough time has passed, we emit a signal and set burning to false. Next scene is flame. I actually recreated this particle generator as exercise. We create a new empty scene and add an area as a root. Then we drag and drop the particle scene in the tree. We also add a new collision shape. Flame should be centered in the origin. For collision, we use a capsule shape and surround the flame. As last touch, we add OmniLight and an audio stream player 3D that we can use to play a looping sound. We save the scene as Flame and attach a new script. We give it a class name, Flame, and add a reference to burnable object. In Ready, we added to flame group. This group is not necessary in this tutorial, but it may be useful in future. And we call a randomized to set a random seed. In process, we alter the value of OmniLight light energy using a random float. We use a random range to be sure the value is neither too high or too low. And we copy the position of the burnable object to follow its movement. We just verify it's not null to avoid any error. Die function simply calls a queue-free, but we could add an animation before it. Finally, we connect area entered signal to this script, and if the area is in group burnable, we simply set to true its burning flag. We can also add reactions to other elements like water, but we will implement them in another tutorial. Last but not least, we create a new scene. It is a special node that we will call Chemistry Engine. The only child is another special node. We call it Flames and it will contain all flames added to the scene tree. After saving, we attach a script. We assign a class name, Chemistry Engine. In Ready function, we use yield on the root of the scene to make sure next operations are performed when all burnables are ready. Then we get all nodes in group burnable and connect their fire start signal to onFireStart callback. Next, we create a variable to store a preloaded flame scene. Then we make the actual callback. We instantiate a flame node. We add it to the flame's children. And finally, we use the burnable area passed as parameter with the signal to set mutual reference in flame and burnable nodes. Now we have all the parts and just need to assemble them. We go back to Torch and drag and drop burnable in its scene tree. We use 3D view to place it where the fire is supposed to be, and we adjust the collision shape. We right-click on burnable node, enable editable children. Click on its collision shape. Go to Inspector and select a new collision shape. We use a sphere and resize it according to the torch. If we edited the original sphere shape, we would have changed the original burnable scene. We do the same for the end torch. Finally, we add to our dungeon scene. We pick one of the torches, enable editable children, select this burnable scene, and in Inspector we set burning and permanent to true. We drag and drop our chemistry engine in the scene and we can press play. And it works. Finally, we can change the particles to use local coordinates, since I feel the character moves a little too fast for the flame. And we can change the light color to red-orange. And that's all for now. I hope you liked this tutorial. Thank you very much.